Compound interest. Use the compound interest formula A equals P times 1 plus R over N to the N times T power and A equals P times E to the RT power to solve the problem given. Round answers to the nearest cent. Find the accumulated value of an investment of $15,000 for 5 years at an interest rate of 4.5%. We're given 4 scenarios. The first scenario is part A, and that is compounded semi-annually. Now first, compound semi-annually means that we're compounding 2 times a year. And N represents the number of compounding periods in our formula, so N is going to be 2. Now we're going to use this first formula because the second formula is only for compound continuously. All other compounded scenarios are going to fall under this first formula. So we've already identified N. Now we're going to identify P, R, and T. P is the principal, or the initial amount that you're investing. And in the problem, it tells us that we have an investment of $15,000. So P equals $15,000. And it says it's for 5 years, and T is the number of years, so T equals 5. And we have an interest rate of 4.5%. So R is 4.5%. Now in order to plug R into the equation, we have to convert the percentage to a decimal. So in order to convert percentages to decimals, you just take the percent, 4.5, and divide it by 100. So we get a decimal value of 0.045. Now we're going to take all these values and plug it into our formula. A equals P times 1 plus R over N to the NT power. And A is what we're solving for. That's our future value. So when I plug all my numbers in, I get 15,000 times 1 plus 0.045 divided by 2 to the 2 times 5 power. Our first step is to divide 0.045 by 2. When we do that, we get 0.225. Next, we can multiply 2 times 5 to get our power of 10. Now we want to work on parentheses some more and add 1 to the decimal. When we do that, we get 1.225. Now we have A equals 15,000 times 1.225 to the 10th power. Next, we're going to raise 1.225 to the 10th power, and you can do this using your calculator. When you do that calculation, you should get 1.249203426. And we want to keep the entire decimal. Do not round the decimal at this point, or your final answer will have rounding error. You only round decimals when you reach your final answer. Lastly, we're going to multiply that decimal to 15,000. When we do that, we get 18,738.0514. Since this is a monetary value, I'm going to round to the nearest cent. So my final answer is $18,738.05. That's the answer to part A. Part B asks us to find the investment if the investment is compounded quarterly. Quarterly means 4 times a year, so N is 4. All other values for P, R, and T stay the same. We're just going to take those values and substitute them into the compound interest formula. So we have the formula on the screen. Now the first step is to divide 0.045 by 4. When we do that, we get 0.1125. Next, we're going to multiply the exponents together, 4 times 5, and that gives me 20. Now I want to add 1 to the decimal within parentheses. When we do that, we get 1.1125. Now we'll take our calculator and raise that value to the 20th power. That number is 1.250750521. Lastly, we'll multiply that decimal to 15,000. When we round to 2 decimal places, we get a final answer of $18,761.26, and that's our answer to Part B. Part C asks us to compound monthly. There's 12 months in a year, so that means we're compounding 12 times a year, so N equals 12. All other variables stay the same, and we'll plug them into the formula for compound interest. The first step is to divide 0.045 by 5. Then we'll multiply 5 times 12 in the exponent position. Now we're going to add 1 to the decimal within parentheses, and we get A equals 15,000 times 1.00375 to the 60th power. Next, take your calculator and raise that decimal to the 60th power. After we do that, we'll multiply by 15,000, and you should get a final answer of $18,776.94. Part D asks us to do this compounded continuously. Whenever we're asked to compound continuously, we use A equals P times e to the RT formula. So the variables stay the same, and we're just going to plug them into that formula. The first step is to multiply the exponents together. Next, you want to look at your calculator and identify E on your calculator. E is just a natural number, and it's a decimal number. It has a really long decimal expansion, and it goes on forever. So the calculator has that decimal programmed as the letter E. So you'll just find that button, click E, and then raise it to the 0.225 power. When you do that, you should get 1.252322716. Lastly, you'll multiply that decimal to 15,000. You should get a value of 18,784.84074. Now again, we want to round this to the nearest cent, so our final answer is $18,784.84. And that's our answer to Part D.